points to one thing.
All the maths is there. We've got the speed of light in vacuums, all of this stuff.
It made no assumptions. It's a proper proof.
It is. Does not equal rosé.
So therefore,
You do owe me those cookies you said you didn't owe me.
I don't want to get away with that.
Not today.
So now on to normal distribution.
I'll rub this off, but what is normal distribution?
Well, normal distribution is to do with data sets. When you have a data set, most of your values will be quite close to the mean.
Yeah.
And if you plot all your beta values, they'd follow a stereotypical normal distribution curve, which Wayne's going to draw up lovely for us right now.
So this is the axis here, and it
Yep.
would look like...
Roughly like that. So, and this is where the mean would be about in the middle.
Yep.
Remembering in stats we do a strange mu thing.
More like that.
Yeah. And most of your data will be quite close to this.
Yeah, because it's the mean, it's the perfect average. Nearly everything will actually lie within within one standard deviation but either side.
Yep.
So you've got a standard deviation
There and the other side. In fact, all of your data will always nearly
always lie within 3.
makes more sense that way around.
Yeah. And as far as we're concerned at A level, it will always lie within 3. Some data sets are pretty poor and they won't, but not at A level.
Not A level.
So, in fact, 68% of your data, I think the book says, lies within this.
Yes,
Then you
this
have
near is true.
2 sigma.
And then the very, very, very edge.
You've got 3 sigma. And that's
That
where
should be the end.
all of your data should lie within. But where is that useful, Triff?
I was about to ask you just the same thing, Wayne. Well, I do know the answer.
Good.
And in a company, say you're selling hairdryers,
That's a very good typical exam question.
and you have a warranty on these hairdryers, and you want to test when these will break, what the probability they'll break, and how many.
Yes, so say the company that makes these hairdryers in their factory make 10,000 hairdryers a day. I don't know how accurate that is.
If they did, quite a few.
You might make about 10,000. They sell all of these 10,000 onto various superstores, each one perhaps with a year guarantee, year warranty.
And if you have a warranty, you don't want it to break and then come back.
So otherwise you have to get a refund and you won't make as much profit in terms of business.
No, so you do tests, and when you plot your tests, you'll plot them like this. And then you'll want to do a few tests to work out the probability of it not being in with your first standard deviation.
Yes. And the sort of thing you'd get if we're going with the 10,000 made in a batch idea, you'd do what is the chances perhaps of 9,500 succeeding and the other 500 failing, and see what the probability of that is. That's what we're dealing with these curves, these sorts of questions.
Yeah, and you need to know how to do that.
So we'll crack straight on with that right now.
Alright. Now on to using it.
Yes, and for once we have a question that's not a hairdryer question.
No, stats, they love hairdryers. They're like fairground games, they're like heights, and all things to do with school training.
Yes, and in this case, it's school children.
Yep, so there's an example, that's the first example right at the beginning of the book for normal distribution, but we're not going to do it quite like that.
The solution they've done is as an intro to exercise A, well, you're doing it in robot fashion just to be familiar with the sort of territory you're in.
And it's sort of explaining how standard deviation relates to data.
Which is useful, we might refer to it a bit, but we're actually going to do the method over the few pages.
Yeah,
the actual method.
The actual method you'll use normally, because then you can look at it and easier understand it, hopefully. Because this way doesn't always work. So let's crack on with it.
Let's crack on.
So, example 1, page 76, that's page 76. The heights of students at a college were found to follow a bell-shaped distribution.
It's just a normal curve.
Yep. It's normal. And would mean 165 centimetres.
165 centimetres.
165 centimetres.
165 centimetres.
And a standard deviation of 8 centimetres.
8 centimetres?
8 centimetres.
8 centimetres.
One
Solved.
less than
The man at
9.
the back in the red. Carry on.
Okay, so part A is what proportion of students are smaller than 100...
Smaller, is that greater? Smaller?
Smaller than 157 centimetres.
157 centimetres.
160 centimetres.
157? Bingo.
Nailed it. So, let's do that.
Right.
So I think the first step is drawing the curve.
I think it is. So you got this curve, it's a normal curve.
Yep, as they often are. And when you rate a normal mean, we know what it is. It's 165.
And you can put on the other values, 165 plus 8.
As they'd move in sets of standard deviations.
And that's what you could do.
That's what you could do. So, it's asking what proportion percentage-wise are less than that height. So about half the graph we're looking at.
Well, 165 minus 8 is actually dead on the 157 mark, so we're looking at this area here. This is all smaller than that height.
Oh, okie dokie. So, we need to see the z value, we need to find the phi of that, and then 1 minus that, the answer, right?
Yeah, we should just do that, do it.
Wayne, I think, it's a revision video, should we explain how to get
Probably
to z?
explain what we're doing to help them revise as opposed to do a question.
Yeah, so, first, how do we get our z?
So, a z value is found by doing the thing you're doing. It could be a height, could be a weight, an age, something like that.
Whatever, your variable thing.
This time it's a h.
Minus the mean over your standard deviation. So if you put in the numbers we have here, we have 157 minus 165 over 8. So I'll help you this way, put a calculator out.
No need.
I need?
I got it right here.
Oh, okay.
That's minus 8 divided by 8 is going to be minus 1.
Oh, absolutely. So then we just find the phi of that.
First we need to know what the phi of that is, and I'm going to show them how to standardise it as opposed to jumping straight there.
That's a good plan. Okay, so what we have here is a not standardised version of it, but when we're talking about movements of standard deviations and z values, you should standardise it.
And that means the mean becomes 0, and then your standard deviation, your z values make more sense, because minus 1 on this scale
is one standard deviation.
would be out that door in the neighbour's house, and they always play creepy music.
Yeah, so 1 minus 1 here is one standard deviation across.
Yes, because we know that that is the value we're looking for, this area, and that area actually equals that area, and that's one standard deviation away, so that's how Triv knew.
It is. So now we need to work out what the area is.
And that's where the phi thing Triv mentioned in. The phi is represented like that, and the phi of a z value means the area under the graph to the left of whatever the z value is.
Absolutely.
So in this case, the phi of minus 1. So whack out your table, let's have a look.
Alright, let's have a look at this. So it'll just be a bit above the 0.
So it'll be up here.
About like that there. I'm not sure what it is when there's nearly a minus 1 on here.
But that's okay. What you should know about normal distribution curves is that the entire area adds up to 1, and that the entire thing is symmetrical.
Complete symmetrical about your point in the middle, our mean. So minus the area part after minus 1 is the same as the area part further on than 1.
So 1's here, this area is the same as this area here, and we have the phi of 1, and that's what you should always do if you get a negative number.
That area.
That will. The phi of 1 will give us that, yes, we want to actually do 1, which is the area of the entire thing,
minus the area we get. So the phi of 1 is 0.84.
0.84.
Yep, so it's 1 minus that.
So it's 0.16 would be the area.
It
1
would.
minus
0.84. So, and we are at a percentage, so it times up by 100, and so that means 16% of the students are smaller than that height.
So, you're not alone in your small little world.
I think you take the paper, Wayne, and I'll do a bit of writing.
Alright, give me the book as well then, please.
Oh, okay, here you go.
Fine, whatever, I don't even care.
No one knows.
B. I think I should have another cup of tea soon.
You should.
Don't get hit again. Above roughly what height are the tallest 2% of students? So it's looking for the tallest 2%. And they don't really give you any more information than that. Well, they don't give you any more information than that, so that looks terrifying.
It does. I think what I'm going to do first is sort of explain how the book's done it.
Okay, I'll take a step back and...
Oh, alright, so the book did here, before it went, found out what one standard deviation to the left was, then worked out what percentage of that was of 165. This one, it's done a similar thing, it knows 2% is 2 standard deviations across. You go across 2, so 165 plus 8, that's 1 standard deviation, and that is 173. The next one, here, would be the next thing, which would be 181. So they've said that's the height, but it's not always that simple in exams, so we're going to go through the Z way of doing it as well.
Yep, so that is the answer in this case, it does work. So, the other way.
The other way, and this way you have to use the other side of the tables.
You do indeed, so I'll give you back the tables.
Thank you very much.
So, we've got 2%, whereas at the end here we had 16%. So you can picture that we're working backwards.
Yeah, so won't go on from our next step, 6% onto that. But we have 2%, so it goes into 0.02, that's our probability. But
we need to find the value of z for 0.02, except that's not there. So we do 0.98, which is 1 minus that 0.02.
We do.
And that, in fact, is better, because if 0.02 was on there, it would give us the z value and then to the left, whereas we want to the right because it's now the tallest.
We do. So 0.98 is what we want, and that value is 2.05.
2.05?
Yep.
2.05.
2.05.
And that's our z value. And now we know z equals this height, which we're trying to find out.
We do.
Minus the mean over the standard deviation. And the mean and the standard deviation haven't changed, nothing's different.
So we move over our mean.
Yeah, first I would times by the standard deviation, then move it over. But either works. So I'll do that times by 8, which is our standard deviation, and then all of that
plus 165. So
that will give us our height, which is above this 2% value. 2.2.
Okay, Wayne's doing it. Beat me to it.
8, yeah, it did. Plus 165 should give us, and it does indeed, 181.4. These ways are often more accurate because you've got the figures in the table.
But you get the picture. It's the same sort of idea, and every question is sort of like this question, except
sometimes they like to go straight to a question where you sort of work backwards, and these in the book are our further equations. So
this is when you maybe don't have a mean
or don't have a standard deviation.
So I think we should get on that.
Yeah, further equations, let's go, but first a cup of tea.
Oh yeah, definitely.
No, I am certain of it now, Triv.
We definitely can't diffract.
Damn the broccoli. But enough about physicists.
The Plancks anyway.
On to maths with the French and the Picassos and the strawberries and the...
Fish. Lots of fish.
Moderate drinking of red wine.
Absolutely. So, we're on further equations.
Yep, and it's where you don't have the mean or don't have the standard deviation or basically just have to work backwards.
You don't have something. So, we have an example.
We do, and it's quite a mean example.
But normal of the ones you get in the actual exam.
So let's distribute it to you.
Absolutely. So, it's example number 5.
Mambo number 5.
Chanel number 5. Not that I wear it should, because that's supplement. A machine whose packages a standard deviation of 8 grams.
8 grams.
The mean can be adjusted to any given value. The company requires the machine to be set so only 2.5% of the packets weigh less than the weight, which is 250 grams. To what must the machine be seen to be set, or just be set?
Talking in a voice like that, you could narrate books.
I might.
Something to think about. So, this question is a similar sort of structure to what we had before.
Yep, and we need to work backwards.
Yes. So, first we do this percent as a probability.
We do, so divide it by 100, so that's 0.025. But that's not our tables.
No, so to get it on your tables, you do 1 minus that, which gives you 0.975, and find the value for that.
Yep, and it's on tables, and it's on the second page of tables.
So that's the working backwards page.
Yep, and it is 0.975, which is 1.96.
1.96. Now, last time, when we were doing, when it was greater than, so it was the tallest heights, and it was bigger on our little normal distribution like this.
Yep.
We kept it as a positive value, but now that it's less than, this then changes to the negative value because you're coming down here
from
less than.
Absolutely.
So the z value is in fact negative
1.96.
With that in mind, we can then plonk into our equation and find the mean, because we know
we can.
W, we know our standard deviation, it's just the mean we don't know.
Yep, so let's do that.
minus
1.96 is equal to, remembering our equation before,
250.
so our given value times, minus, the mean over the standard deviation, which we know.
Yep, so we then times this by 8.
We do, which is, I'm not sure what my calculator is with.
Alright, I've got it.
Oh, it's over there, alright.
Gives us a value of minus 15.68.
Alright, 250
minus the mean. Then you take this over, it becomes a minus.
Okay.
So you're going to get minus
65.68 equals the minus mean, which must mean you times both of them by -1, remove the minuses.
Yep. The mean, which is what we were trying to work out,
it is
265.7 rounded up.
Rounded up.
And that's why it's important to know it's the negative, otherwise you get a negative mean, which would be miles off. Because you don't get a negative mass.
So, just to reiterate, maybe you should shade in bits of the graph that we spoke about last time.
Okay, so we have a mean, we don't know what it is. This is what we're trying to find out. And we want to know how much falls beneath this 250, and they know that they don't want it to fall beneath that, which implies the 250 is going to be somewhere.
Yeah, to be this side.
And we don't want them to fall below here. So we standardise this
the mean
to get
0,
and find out what this z value that corresponds to that is.
And that's what we did then, and then became a minus because it was that side of the 0.
Yes. So that's how you know. When you standardise this and look at what you're dealing with, you know if this is going to be negative or not. Then you just do what we normally do.
And that was the answer.
Yes, so now I think it's time for a test yourself.
I think it is.
And then we'll sum up, so we'll see you at the test yourself.
Alright, let's do that. Question time.
Yep. Test yourself, page 89, question 7 from this book.
Purple.
We chose it because of Fred. Has Fred in it.
It has a Fred in it, and it also has someone else. Sid. So, Fred and Sid walked into a bar. Ow.
7A, part 1.
Yeah, it's quite a long-winded question. We'll get through it.
I'll battle it out.
Battle it out. It says the time, in X minutes, taken by Fred Fast,
I reckon he's pretty quick.
I reckon he's pretty quick, to install a satellite dish may be assumed to be a normal random variable with mean 134.
134?
134. One less than 135. And standard deviation of 16.
16?
16.
You mean 4 less than 20?
I do.
Right.
Part I is determine P, open bracket, X is less than 150.
And that's the form it will be written in the exam.
It will. Now, I reckon those from the beginning a while ago.
Yeah. Have a mean, have a standard deviation, and we have a value, and we're trying to work out the probability.
Yep.
I think I can float quite nicely with this one.
Alright.
150 minus 134 over 16 to give us our z value.
Which is?
16 over 16 is just 1.
Just 1, yep.
And then we need the phi of 1.
So
and that will give us everything to the left of whatever this z value is, which is correct because we want it to be less than 150, which is greater than 134.
Yep, so it's 0.84. Do you want any more?
I think we should leave it at that.
Alright.
So just to be clear of what we're going through here, the mean is at
134.
and we've got a value of 150 and we're finding out the probability that it's less.
All of that area there. Which is quite a lot of area.
We could draw the standardised version, but this one's quite easy to see what we're
Yep.
doing. So that's the answer.
So, then there's a part 2.
There is.
And that says, determine to one decimal place the time exceeded by 10% the installations. So that's exceeded, so it's greater than.
Yes. Okay, firstly, get the percent as a probability.
So we divide that by 100, so that's 0.1.
That's not on the table, so you do 1 minus that, so we want 0.9 and the z value that corresponds with it. That's over the page, Drift.
I thought I'd really hand it. I hadn't, but I had.
Did it twice.
Done it twice.
It's like a time turner.
Yep.
3 times to do it.
1.28.
1.28.
Yeah.
That's that's the Z value.
Yeah.
What's the question?
It's to work out, determine to one decimal place, the time exceeded, that's greater than, by 10%.
Right, so we've got our Z value, we've got everything but T, which in this case is our variable. So we've got T minus the mean, which hasn't changed.
That'd be 134 over 16 equals 1.28.
So we times it
By 616.
and then we
plus 134 move it across.
equals our variable T.
Yep. Which means our variable
Drum roll, please. Another one, please. 154.5 to one decimal place.
Alright.
Like that.
Okie dokie.
There's a part B with Sid Slow, I believe.
There is. So this is Lad Slid. There's his lad Sid. And the time, Y minutes, taken for him to install a satellite dish may also be assumed to be a random variable. And when I say random variables, or normal random variables, you know it has to be stuff with this.
Yes.
Just thrown out there. Where, so P open bracket Y is less than 170.
Y is less than 170.
Close bracket equals 0.14. And P of, again, the same thing, except Y is greater than 200. And that equals 0.03.
Right.
So determines the nearest minute value for the mean and standard deviation of Y. But that, Wayne, that means we have two unknowns.
We do, but it's fine, don't panic. We have two things here, so we're going to have two equations we can
Simultaneous equate them.
Yes.
All
So
right.
this brings back some cool one things with this fabulous stats thing.
And you can't forget these.
You can't.
So,
This 170 minus an unknown mean over an unknown standard deviation equals not 0.14.
no.
That 0.14 is a probability, because it's the probability of this equals that. We want a Z value when it's in this equation. So to find out the Z value, you can do the 1 minus 0.14, which gives you 0.86.
It does.
And then if you find out the Z value of that, because it's less than, it will be negative whatever that version is.
So,
0.86 please, Triv.
0.86.
And I'll just put a minus here because we know what it's going to be.
1.08.
0.08. And same thing for the other one, for another equation, you're going to have 200 minus an unknown mean over an unknown standard deviation equals, this time it's going to be 0.97 please.
Yep.
And it's going to be the positive version, yes.
So 0.97 is 1.88.
1.88.
Yep.
1.88.
Right.
If you times these both out to get rid of this dividing sign.
Yeah. So that'd be 170
Okay, 170
minus the mean.
I'm going to put equals because I want these two things over the other side to be in the form I'm used to. That's going to be the mean minus 1.08
of the standard deviation.
standard deviations.
And then we do the same to this side.
So 200 equals, again I'm just going to fling the mean over there,
Yep.
although you do the other bit first.
Then that's
Plus
plus 1.88 of the standard deviation. Right.
So,
Yeah.
the means have the same coefficient, we can minus one from the other.
Doesn't matter which one we minus from which.
No. I think to make things easier I'd rather do this one minus this one,
Okay.
because that would give us a
Gives us a
positive
30.
value of 30,
Yeah.
and that minus that adds it,
It does.
so that'll be
2.96.
2.96, I
Of-
make it 2 of that.
Yep. Then we
So that
divide
means that
30.
equals
by this 2.96, giving us a standard deviation of 10-ish.
point, hold on. Wait, how many decimal places does it want it to?
Um,
Forgotten.
forgotten. I think
I
it was.
think it was just as a minute, wasn't it? So rounded to the nearest minute.
Yes, it was the nearest minute.
So that is just 10 as a standard
Oh,
deviation.
cool.
Then we can put that back in, and that's a friendly little thing. I'm going to put it
Okay.
into that one because that one's negative, and I don't really like that.
Oh, okay.
So 10 times that is 18.8. 200 minus that 18.8 gives a mean of 181 rounded down.
Yes.
Yeah, I make it that.
18 point. Yes, because it would be 181.2.
Yeah,
But
that's
we're
what I
rounding it
get.
down.
So I'll
Okay.
write these values back up here. We have that equals 10, and our mean equals 181.
So the hard part of this question really was just the end part. We had to notice one was minus, one was positive,
Yep.
and notice it's a simultaneous equation.
And that's quite tricky.
It is. When they have two unknowns, there's always going to be something like that because you can't work it out otherwise.
Yeah.
So, this is test yourself question. That was a summary.
Summary, yeah, let's go.
Let's crack that. Summary time.
Normal distribution.
Who's going to hit me again?
I wasn't. The chances of that happening was so low. We need to do a card trick soon, actually, because this time you won't cheat. That's what I'm hoping. We'll do that. We'll do that tomorrow,
We'll do it.
probably.
Yeah, do it later. We'll make up the sum. So, we started off saying what is normal distribution?
And why is it useful? And it's the pattern that trends of data will show, with most of it being close to the mean and some of it being the extreme values.
And you've got to know that nearly all your data will be in one standard deviation and all of it will be in 3.
3. And then the uses is stuff like business. If you have warranties or something like that on stuff, cars use it all the time. Obviously, you don't want your car to go bang.
And if you do, you're going to be after the warranty. Well, the companies do.
If you're going to make it go bang, you should do it before.
Yeah.
And you get your money back or something.
Or something. So here's working at your Z values.
Yep, and Z is the value you've got minus the mean over the standard deviation.
Absolutely. And then once that, that's called standardising it. Then using that you can work out what bit of the graph you're trying to find the area of.
Yep, and then you do the phi of that Z value to find the area.
Yep.
Which gives you the probability within the area.
To the left of that.
To the left of that,
And
always
then
to the left.
Maybe you might, because maybe it might be to the right, you might have to find the other one.
Yeah, you might have to do one minus it or opposite.
Or opposite, yeah. And sometimes you don't have the mean.
Yep, so that was our further equation. Sometimes you have to work backwards. You normally start with a percentage, then convert to probability. Sometimes they'll just give you a probability, but it's the same steps, obviously. And then the hardest they really get is giving you those two.
Yeah, two unknowns with the simultaneous equations.
That's about as hard as it can
That
get
is about
in
as hard as
terms
it
of
can get.
challenging maths.
And that's pretty much normal distribution.
Yeah, we did our test yourself. It was 2003, I believe. It could have been 2002.
But it was an exam paper.
So it could come up. Well, does come up.
Does
If
come
you look
up
at your
all the
papers, it comes
time.
up a lot. Yeah.
If you found one that you're finding particularly hard,
Message us on Facebook or in the comments below.
and we'll try and get it back to you personally. But, sorry, if lots of people send it to you, send it to us.
Then we'll just put it on YouTube and tag you in it on Facebook, let you know it's there.
Yep.
And we go through it in much more detail if you have a problem, because this is just skimming the key points. If you struggle with a
is.
particular thing, we go through everything on it.
Yeah, and why each step happens and stuff.
So hopefully you'll find that useful if you need it.
Yeah.
But for now, we've been Clever Cracker Squared.
Yeah.
We'll see you next.
This is a good cup of tea. It's a good cup of tea. Oh, yeah.